Okay, so in this video we'll be talking about the LED, which stands for light emitting diode. The LED is a two-terminal device. You can see the two terminals here. The longer terminal is the positive, the shorter is the negative. But that terminology is wrong, because if I cut the terminals they will be equal. What we have to look for is, if we have an LED, you can see inside there is a smaller plate and there is a bigger plate. Okay, so the smaller plate is for the positive, the bigger plate is for the negative. Just remember that. The LED stands for light emitting diode, so it's form of a diode. For diode, the electrical symbol is this. This is the positive, this is the negative, anode and cathode. So to work with the LED we need two important things: the current and the voltage drop. So what is the voltage drop? Suppose we have two resistance and a battery, say the resistance R1 and R2. For example, the potential difference, okay, the potential difference which I apply between these 2 points is, say, 5 volts, not 5 volts, let's say 6 volts. So what will be the voltage drop across these two? When I say voltage drop, I use the word drop because, like, you have to imagine that this resistance would eat up some of the voltage which is going through it. 6 volts, suppose this resistance is very hungry, it will take in, say, 5 volt. Okay, so what will be left for this resistance? Only 1 volt. Or you can say that this resistance is taking 1 volt and this resistance will be taking 5 volts. So the voltage drop across this resistance will be 5 volt and across this resistance will be 1 volt. You can then this is determined actually by the equation V is equal to IR. So since the current through both of this is same, constant, so definitely we can see that the resistance which is higher will have a greater voltage drop and which is lower will have the lower voltage drop. So this is the concept of voltage drop. The same thing happens with the LED. Now if I connect the LED with a resistance here and a battery of V volts, definitely a voltage will be dropped here, V1, and then V minus V1 will be dropped for this resistance. Now one of the important things with LED is that the voltage drop through the LED remains rigid. By rigid I mean, you can practically you can see that the voltage drop across an LED will always be between 1.5 volts to 2.0 volts. It can vary depending on the color of the LED, but in most I use red. So for the red LED, the voltage drop will be between these two values. Okay, now see, for a resistance, if we find the voltage drop V and we know the value of R, then we can easily say what is the current using the relation V is equal to IR. Now we also need some relation for the LED, so that suppose someone asks me that I am giving a current of I amperes through the LED. So what will be the voltage drop across it? So that when I use another appliance here, the rest of the voltages will be dropped in here. Okay, so I need the value of voltage drop here so that I can calculate what voltage will be dropped in this appliance if I have potential difference across it. For that we also need an equation which connects I with V. Okay, there must be some relation between these two. Now the diode, the LED, is not a linear device. Okay, for linear device the equations will be linear. For example, the resistance is a linear device, due to which this equation is linear. You can plot a graph of V and I and you get a straight line, okay, whose slope will be R, but this is not the same with the diode. Now if you plot a graph, okay, if you plot a graph of I versus V for a diode or an LED, you see that the graph is somewhat like this, then there's also negative current, very small current which goes through it. This is actually a graph of a diode, and at some point, say this point 2 volts, when you exceed 2 volts, okay, the current through the diode will be immensely high and that will actually destroy the diode, so you should not go above 2 volts. Anyways, for this range we are interested in this range. For this range we need an equation, right? Now, okay, so here we discussed that we need a equation between I and V. Okay, this is ID is equal to IS into e to the power Vd by Vt. Here ID is the current through the diode, ID, and Vd is the potential drop across the diode. Vt is equal to N K T by Q. Q is the charge of an electron, T is the temperature, K is the Boltzmann constant, and N is the ideality factor. N's value is between 1 and 2, and like it depends on the material. Like for germanium it is around 1.49, so I'm using 1.49 as N, and since this is constant, this will be constant taking room temperature, and Q is constant, so I get a Vt value of 25.85 millivolt. This is for most of the diodes, and I have taken the same value for the LED. Now the IS is called the reverse saturation current. We know that Vt is equal to 25.85 millivolt, so this is fairly constant. Now if this is constant, this term in this equation, and if this term is also constant, then we will have a clear relation between ID and Vd. That means we will not have to depend on any other quantity. We can just put the values and we get the answers. But the problem is 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 not constant, like, because I've carried out an experiment where I took a variable resistance and a diode, and I calculated the current going through the diode and also the voltage drop across the diode, which is the LED. Then I found out that if I keep changing the resistance, and as the current increases, so does the voltage drop across the diode increases. Then if I take out the IS values for every value, then I should get a constant value of IS, right? For every Vd and ID, if the IS is constant, then I should get a constant value, but it is not constant. It varies a lot, from 24 to around close to 0. It's like completely 0. So we cannot depend on this equation, because there is one quantity which is not constant and it depends on something else. Now what does it depend on? So the IS depends on a lot of factors, like temperature, the doping level of the diode, the structure of the diode, the geometry. It depends on a lot of factors. So it becomes very complex for us to carry out the equation where a value which is dependent on so many factors is there. So what we need to find out is a simple model. For that, the simple model is using the graph. Okay. Now to make the graph, I would recommend you to follow the steps. Okay, the first step that you should follow is to make sure that the current through the LED does not exceed 10 milliampere. In this case, this LED, okay, the red LED we have. If you have this LED, then just make sure the current does not exceed 10 milliampere. And so in this, suppose we are keeping the highest point of current as 10 milliampere. So if we keep this at 10 milliampere, and we have to find the resistance which we should use for our first reading. So this is how we can find out. Keep the voltage drop across the diode to be around 2.0 volts. So the voltage drop across the resistance will be 3 volts. We are using a 5 volt battery. So for V is equal to 3 volt and I is equal to 10 milliampere, we should have a resistance of 3 by 10 100 ohms. Start with 300 ohms, then you go up, and it does not matter how up you go, just make sure that the LED is on and you can visibly see it. So start with a resistance of 300 ohms, and if you suppose you have a resistance, the current and the voltage start with 300 ohms, you get a value of current which is very high, suppose 10 milliampere. Then voltage will be 2 volts across the diode. Then you go up to suppose 330 ohms, then maybe 500 ohms, maybe 1k, then 10k, 100k, like this. Use a potentiometer, okay, so that you can get values between these two values. These two values, the more number of values you take, the more accurate your graph will be. You will then, after taking all the values, you will come up with a graph which will look like this. So here at a point of 2 volt, you will see that the graph steps up. Do not exceed 2 volts. Just you will know, do not exceed the 2 volts. Okay, now in the current you use a maximum current of 10 milliampere, so that you get all the values up to even microamperes. You get the values in this range. You will get all the values of from 0 volts to 2 volts. So now you will be able to see how easy things become once you have the graph. Okay, the graph which you build is here, ID and VD. You have a graph. Now if someone asks you that make a circuit where the current through the LED must be 5 milliampere and the battery that you have is 20 volts, he just gives you these two values and you have to design a circuit. So let us design the circuit. See, the current is 5 milliampere. So to get the value of R, we have V is equal to IR. We do not know R, we do not know V, we just know what is I. In this way we won't be able to solve the equation. So we need to find what will be the voltage drop across the resistance. Okay, so that we can find, that we will get if we know the voltage drop across the LED. How will we find that? Using the graph. So look at your 5 milliampere point and trace it back to the voltage which you get. So suppose VD gives me around say the values which I took, I'm just saying 3 and 8. So 5 will be between this, say I'll say 1.95. okay, say the VD is 1.95 volts. So what will be the voltage drop across the R? R will be, suppose I have 20 volt, so 20 minus 1.95 will be the voltage drop across the R, which will be the V, which gives me 18.05 volts. Now to find the R, I simply have to put the values in the equation. I know the V, which is 18.05, and the current, which is 5 milliampere. So if I have, so in this way I can find okay, the R is 3601, which is 3.6 kilo ohm. So if I have a resistance of 3.6 kilo ohm here, then the current through the LED will be 5 milliampere, and we will not be harming our LED, and it will glow. So this was my intention, to make the development of the circuit easy, and when someone asks the correct questions, you can easily make a circuit. Okay, so thank you for watching. If you find a relation between ID and VD for the LED, please let me know, and I'll be making more videos explaining the different components of electronics first, then I'll go into projects. I'll not go into projects directly. So yeah.